Hi everyone, and a very good evening to the first December daily challenges. For those of you who are new and don't know what's going on, Edyst conducts these daily challenges to help you gain knowledge about a particular topic. This time's topic is December daily challenges, and its theme is dynamic programming. And in this theme, we are going to cover a bunch of concepts of dynamic programming. So this is how the rules of it goes off. You can sign up here. That's the link that's given, and the link is also mentioned in the description below. It starts from 7th December 2020, and every day at 6 p.m. We will launch a new challenge. Sharp 6 p.m. a challenge will launch, and the solution will be released on the same day at 9 o'clock. So you don't have to wait too long. You have between 6 to 9, because after 9 everybody will get the solution, and so you should try to do it as soon as possible. The first to crack the challenge for that day is on top of the leaderboard for that particular day, and this is ideal for all students preparing for product companies. Especially, a lot of students are very scared about dynamic programming, and that's our theme this time around. I know I get these kind of photos about what is this feeling, this dynamic programming, this is just something else. And brace yourself, more dynamic programming is coming. We don't want to scare you with dynamic programming, and this is exactly what we've made these daily challenges about. That seemingly easy and not too difficult questions are there in dynamic programming, provided you have enough practice and you know what you're supposed to do at that point. Okay, and again, if you don't really understand it, or if you want a more in-depth thing, then I urge you all to look up the Advanced Algorithms and Data Structures course by Edyst. It is also aimed at product companies, but we don't just stop at dynamic programming. We in fact cover the entire syllabus on that one. And just a quick thing about that, you can sign up here. That's the link for the Advanced Algorithms course. And we have more than all of like 300 questions of all of the previously asked product companies. Weekly sessions are there with instructors. I am one of the instructors, and you have referrals to companies, monthly assessments, and so on. So it's great. I have covered this up previously as well. You can check out the YouTube channel of Edyst. This is a paid bootcamp, but when it comes to the December daily challenges that we are doing today, that is not a paid bootcamp, and in fact this December daily challenges are completely free. So if nothing, try your best to, at least for these next 5 days, try to sign up, understand these dynamic programming questions, and at the end of the 5th day, if you are on top of the leaderboard, you can win some exciting prizes as well. So with that said, let's go to our first challenge for the day, or first challenge for the series. That's the December daily challenges. The first challenge and the day one challenge is called weird function. It's called weird function, and let's open it up on the Edyst platform and check what that weird function looks like. Okay, let's open it up. So you have come across a weird looking mathematical function. That's what this says. F of n is equal to n raised to 1 into n minus 1 the whole square into n minus 2 the whole cube into so on, all the way up to 1 raised to n. So what's happening is that the base is decreasing by 1 and the exponent is increasing by 1. Now, for those of you who've probably seen coding questions before, you might think, hey, this is a very simple pattern based question. In fact, this can be solved using a for loop. Why are we bringing in these concept topics of dynamic programming here? Keep looking on, you'll understand why we're doing that. In order to pass this challenge, you must find the value of f of n for any given value of n. As that number might be large, do this. We'll come to this at the end. This is a very critical thing in most product based and advanced questions. Forget it about being the dynamic programming or not. This is one of the most critical things that is there. And in this question, the first line contains t, the number of test cases, and the next t line follow, each containing a value of n. So you have multiple test cases. It's not like just one test case, you have multiple test cases that's happening. Okay. Now this is where things get interesting. This is the constraint. So you could have up to 10 raised to 5 test cases. Each of those test cases, you could have n going up to 10 raised to 5. This is a little bit of a hint that, when you have something as big like 10 raised to 5, this is the hint that is that you can't really just do a single for loop and find the answer. Had this been like 10 square, or yeah, even like 10 square, like 100 test cases or so, you could have still thought of, just going, but 10 raised to 5, 10 raised to 5 is way too much. Okay. So let's try to figure out what's actually happening. So for example, for the input is given to you two test cases. For first n is 1 and the second one is 4. So in the second case, what you're doing is exactly this. You're doing about like 4 into 3 square into 2 cube into 1 raised to 4, right? That's exactly what's happening here. 4 into 3 square into 2 cube into 1 raised to 4, which is nothing but 4 into 9, 36. 36 into 8 would give you 288, right? That's why you got 288 over here. And in the case of f of 1, 1 raised to 1 is equal to 1. Now, whenever we talk about dynamic programming, what people try to just say is, yeah, take the previous value and then do something with that in the next value. Except that I don't think you can apply that directly over here, simply because this is not a recurrence relation. That is, f of n is given as n something. You're not given how it relates to n minus 1. So you're not given for f of n what is f of n's relation to f of n minus 1. It's not given. We could probably derive one, but it's not given. So it's not very obvious all of a sudden that whether it's a DP question or not. DP is short for dynamic programming. So let's come back to our slides and understand what exactly could be the next step, right? This is what it looks like for us, right? Like f of n, this is exactly what we saw right now. And in fact, we did for 4, but we can look at for 5 as well. It'll be 5 raised to 1 into 4 square into 3 cube into 2 raised to 4 into 1 raised to 5, right? That is what we could do. That's what f is f of 5. So for something as simple as and trivial as this, what you could do is the brute force approach would be just by calculating by a for loop, right? And you could just find the answer by for loop, and you could try that out, but you'll get a time limit exceeded. And so for those of you who are new here, let me just show you by actually trying it out by a simple brute force approach. You'll get a time limit exceeded simply because there's just too much there. So let me just open it up on the Edyst platform and just show you that you could try, and I'll do it in Python because it's very easy to understand in the pseudocode way, but depending on your programming language, you can also do it. So I'll just take t is equal to input. Let me keep it small t, right? And what I'm doing is for case in range t, I'm going through all of the possible cases, right? And what I'm saying is, let's take n as input. N is equal to input. Once I took this, what am I going to do? I'm just going to find that basic pattern, right? And what is the basic pattern? So for base in range, your base is going from 1 up until n, right? So I'll do n plus 1 over here, and 1 we raise to n, 2 we raise to n minus 1, 3 we raise to n minus 2, and so on, right? If you can just look at it here, this will be n, so the one previous to it will be n minus 1, and so on, right? So the exponent, let's initially take the exponent to be n. Exponent is equal to n, and what we'll do is for each of the bases we are going to reduce it, right? So for the first one, let's say current is equal to base raised to exponent, right? So we have it raised to some exponent value, and then what we do, we will reduce exponent. Exponent is equal to exponent minus 1, and this has to be a product, right? So I'm going to do product is equal to product into current value, right? And you could do exponent is equal to exponent minus 1 after this as well. That doesn't really matter, right? And I'll keep product is equal to 1 initially. That this is where all my product will go in, right? So current is equal to base raised to, so let's say 1 raised to 5, then 2 raised to 4, then 3 raised to 3, then 2 raised to 2, and then 1 and 5 raised to 1. Sorry, I messed that up. It's 1 raised to 5, 2 raised to 4, 3 raised to 3, 4 raised to 2, and 5 raised to 1. That's how this will go. This will keep going, right? And then all I need to do is just print the current value, right? So I'm just going to need to print the current value, and technically that should be done. There is a big modulo as well, but let's even do it without the modulo and just try it out 1 second. So when you run it, okay, we are getting a wrong answer here to begin with. So we obviously made some mistake in our this itself, our the brute force approach itself. And what was the possible mistake that we've made there? Current is equal to base into this, product is equal to, okay, we are supposed to print product, not the current value. So a small mistake in that. Yeah, so now we're getting this for run, that is for a small test case for like 1 and 4 we're getting. But the moment we have like really large test cases, this would just give us a time limit exceeded, right? So it's passing one test case, we got 1 point, and that is probably the same as our first test case. But everything else, we are getting a huge time limit exceeded everywhere. It's not even a wrong answer as such. So that modulo could cause a wrong answer, but forget reaching that modulo. We are getting a time limit exceeded because that entire loop itself is not, compiling. So we need to find a better solution. So a simple for loop is not going to help us. And as I mentioned at the start, I mean, I did not need to show this brute force, but the only reason I showed is when you have like really, really big numbers, imagine there is going to be 10 raised to 5 test cases. For each of those 10 raised to 5, imagine if n itself is 10 raised to 5. So you're going to have 10 raised to 10 computations, right? Because for each n, you are doing like a for loop of, up until n value. And you're doing this for 10 raised to 5 test cases. So what you want to actually do is you want to be able to find in a way that you can at least store all of the answers somewhere. So when, let's say you have to go through all the 10 raised to 5 test cases, but once I've gone through the 10 raised to 5 test cases, can I answer them right away instead of calculating it again and again, right? And this is the essence of dynamic programming. That is, you try to use a previously computed solution to generate the new solution. But to even figure out that we need to do that and what to do, we need to even understand how the previous solution can affect the new solution, right? So in that sense, what we're going to do is, let's think a little bit more about here, and let's go back to our function. And we said that, f of 5 is equal to 5 into 4 square into 3. Let's expand this. So what you're going to get is 5 into 4 into 4 into 3 into 3 into 3 into 2 into 2 into 2 into 2 into 1. This is what you're going to get. And in fact, there'll be 5 ones. In fact, there will be infinite ones. So that's not a problem as such, right? This is what we get. Can we start seeing a particular pattern over here? There is a particular pattern. If you don't really get the pattern, I suggest you pause it right now, and then you can catch the later stuff, once you got the pattern. But take a pause over here, like pause this video for a second and try to find a pattern that you get. Okay. And now for those of you who don't want to pause and just want to continue, I'll just show you. But again, for those who want to pause, you can just pause and see what's the possible pattern you can get. And what the pattern it is that you see that you can get 5 into 4 into 3 into 2 into 1 into, let's take a bracket here, 4 into 3 into 2 into 1 into 3 into 2 into 1 into 2 into 1 into 1, right? Because I have only one 5, I have 2 4s, I have 3 3s, I have 4 2s, and I have 5 1s. So I can do this, right? And now I think you must have all got it. F of 5 is equal to 5 factorial into 4 factorial into 3 factorial into 2 factorial into 1 factorial, right? Or just 1. So now we have a certain value, right? So we can see some function. So for example, for f of 5, I know it's a product of all of the factorials up until now. And if you know anything about dynamic programming, or if you might have done something about dynamic programming, calculating factorial is not really that difficult, because a factorial is a recurrence relation, right? Where factorial of n is equal to n into factorial of n minus 1. So getting factorial to be computed dynamically is easy, and it's not very difficult. I can just create an array and I can just keep getting the remaining values. So I got this, and now I want to get the product of the remaining values, right? I want to get product of the factorial. So I can very easily say that product of n, which is nothing but f of n, is equal to product of n minus 1, right? Whatever was the product up till the previous one, into the factorial of the new number that's coming in, right? Just take a pause here and figure out. F of 4 was 4 factorial into 3 factorial into 2 factorial into 1. F of 5 is 5 factorial into 4 factorial into 3 factorial into 2 factorial into 1 factorial. So you can actually classify this as, right, f of 5 is equal to 5 factorial into f of 4. So I can very easily say that product of n is equal to product of n minus 1, which is nothing but this f of 4 over here, into factorial of n, right, which is 5 factorial over here, right? So now with that we have a recurrence relation, we can now start figuring out that if I calculate all of, it was said that n, the greatest value of n you can get is 10 raised to 5. Whatever is the greatest value of n, if I calculate till there, let's say what I mean to say is, let's say if I calculate up to f of 1000, then getting f of 100 is very easy, because I've already calculated f of 100 to be able to get to f of 1000. Similarly, if I've calculated up till f of 5, I know for sure what is the value of f of 3 and f of 2 and f of 1 and f of 4, because to get to f of 5, I needed to have calculated f of 1, f of 2, f of 3, f of 4. That is what essence of dynamic programming is. Store some of the previous values to inform you with the later values. Okay. So just to give you a further example how we do it is, we'll probably create 2 arrays. One is for factorials and one is for products. F of 1 is equal to 1. We don't have to worry about that. So this products is nothing but f itself. That's the function that we need to do. and this is factorials. So now factorial of 2 is nothing but 2 into the previous number, so that will be 2 into 1. Then this will be 3 into 2. But once we've got this factorial, now how do I calculate this number? As I said, what was our recurrence relation? Our recurrence relation was prod of n is prod of n minus 1 into fact of n. So we got fact of n over here into product of n minus 1, right? So we got over here 2 value. Okay, so far so good. Here I got 6. Okay, now what I do is 6 into 2 is going to give me 12. So that's the answer here. Okay, what did I get over here? I got 24. So 24 into 12 is going to give me the answer over here. What is 24 into 12? It will be 288, as we just saw, f of n. And 24 into 12 is nothing but 12 into 12 into 2. So 144 into 2 is 288 as well. That you can get there. Now this is 120. 120 into 288 is what will give me f of 5. Right? And you guys can go ahead and calculate that one. Let me also very quickly calculate that. 120 into 288. That's 34560. So the number grows really rapidly, right? The number is growing very fast, right? If you look at it, like the number grew, I think by I think 2 digits. Yeah, it's grown by 2 digits. So like a magnitude of 2 is what it's grown by. It's crazy, right? And that is why it is asking you to take the modulo, by the way, which I'll come to at the end of this session, just to give you a little bit perspective on modulo. That is part of modular arithmetic, but we'll come towards the end. So this is how it probably calculate. And if you notice, now if I ask you, okay, you calculated f of 5, what is f of 4? F of 4 is 288. F of 2 is 2, right? F of 3, it's 12. And you can verify it as well. You'll get the same answer in the verification as well. Yeah, so this is how we'll go about doing it. Construct 2 different lists. One is for the factorials, one is for the products, right? And so that's our approach. Let's actually check out our approach over here, right? So take the maximum number for which the factorial has to be found. This is the crucial part, because while this is great, we don't want to keep doing this again and again. If we find till the maximum number, let's say that was, in this case, it was 10 raised to 5 as per the question. So let's say we find all the way up till 10 raised to 5. We actually don't need to find till 10 raised to 5. I'll come to that while we're doing the solution. But let's say we find all the way there. Any test case that is coming is between 1 and 10 raised to 5. We will have found all of the values between it. So calculate all of the factorials till that particular point. Then calculate all the products till that point. So once you calculate a factorial till a particular point, the product calculation is very easy as well. And then for every query, simply refer to the products list. That's what we're going to do. Okay, let's go back to our I'll copy this one so that we can refer this in our comment section, and let's go ahead and solve this part. So this was our brute force approach, which didn't really work out. Let's put this as a comment here. Take the maximum number for which factorial has to be found, right? So I'm going to delete some of this part. This is the input taking part where I found n. What I'll actually going to do is I'm going to say I'm going to keep a maximum number, right? And I'll assume that to be 0. And what I'm going to take as maximum number is equal to max of n comma max n. What I'm just doing over here is, by the end of taking the inputs, right, I will have found out which is the maximum number that is present in our test cases. That is the number for which I should calculate all the factorials until and all the products up until, right? So maximum number is equal to max of n comma max n, right? And I got that maximum number at that point. So now notice here another trick. What we're doing is we're taking all of the test cases. I'm not computing the answer to the test cases right here. I'm going to compute the answer of the test cases just once, and then I'm again going to go through this loop and answer each of those test cases. So to be able to do that, what do I need to do? I need to be able to find I need to be able to go back to the test cases, right? So in that sense, what I'm going to do is I'm going to store all of the answers. So I'm going to say, let's keep test cases here. Let's say TC, that's my test cases array. Let's write a better thing, right? Everybody, let's write better variable names. Test cases is equal to, let's say 0 into T, right? Because that is the thing. And what we say is TC of case is equal to n. Basically, I'm just storing all of the n's for which we are supposed to give the answer for. That's all I'm doing over here, right? Okay, now that we have done that and we found the maximum number for which we need to find the answer, Now what am I going to do? I'm actually going to calculate the products. I'm going to calculate the factorials. So facts is equal to, let me just initialize everything to 1 initially, and till the maximum number, and I want to do 1 based indexing, so I'll do +1, so that I can actually do fact of 1, fact of 2 instead of doing fact of I minus 1, right? And so I'm doing 1 based indexing here instead of 0. So the 0th value I'm just going to ignore overall, right? And similarly with products, so prods is equal to 1 into max of n, max n plus 1, right? This is what I'm going to do. So now what I want to do is calculate the factorials and the products, right? So I'll do for I in range length of factorials, right? And I can actually start from 2 because 1 is actually correct. So I could actually start from 2 and go all the way up. And what I'm going to do is I'm going to say facts of I is equal to facts of I minus 1 into I. This is straightforward. 5 factorial is 4 factorial into 5, right? 5 factorial is 4 factorial into 5. So the previous one ahead. And as we saw, prods of I is equal to prods of I minus 1. Okay, so the prods of I minus 1 into the fact of I. That's the latest factorial that we got. So it's going to be facts of I, right? That's the thing we got. So we calculated this. We got all the products so far. And once we have done this, what do we want to do? We want to now go through all of those test cases again. So this is your f of I basically, right? So I'm going to go through all of those test cases again. So I'm going to do for case in TC, or rather for for test case in test underscore case. I think we messed up this part. Should be test cases here, test underscore cases. So for TC in test cases, for each test case that is there in test cases, simply what I'm going to do is print prods of TC, right? I'm not iterating by index. I'm just iterating by an iteration itself, not by index. So each of the test case will actually be a value of test case itself. So I'm going to do prods, print the prods of TC, right? I think that should be it. We've still not covered modulo, by the way, but let's just see if this runs, that we have any small, okay. So we're getting the run part. Let's submit and check. We'll most probably end up getting like wrong answers, maybe a time limit exceeded. Yeah, okay. So we're still getting a time limit exceeded. You might be wondering, why exactly are we getting a time limit exceeded, even though we did all of these amazing, modifications, and we did a dynamic programming approach. See, the reason you might still be getting is you're multiplying very big numbers, right? So when you start multiplying big numbers, Python itself is going to use its libraries to start multiplying the big numbers. To specifically counteract the big numbers, we have been given this really big number in which you have to take modulo. So what it will do is, what is the property of modulo? It will always keep the numbers from 0 up until n minus 1, right? If you're taking modulo n. I'll just quickly cover that with all of you, why we actually take modulo. So let's say if I take, very big number n, not a very big number, but I'm just saying a number n, and let's say I do, modulo n, the only possible values you're going to get are from 0, 1, 2, all the way up till n minus 1, because the remainder cannot be n or greater than that, right? So if we do all of our multiplications under this modulo, then what we're going to do is we will cap the number between 0 to n minus 1. So we always know for sure that the number fits in our integer. Now in the case of, or it fits in a long or whichever data type we're doing. Now in case of Python, we don't really have that many data types, but this is especially useful for C++, Java. Also, when we're calculating really big numbers, we are again run into this issue of calculating really big numbers, right? And Python will then start treating it as objects and start multiplying objects and so on. But whereas we keep them small numbers, then it's very easy for Python or any programming language to really quickly compute them. So we have to do this modulo n. Modulo itself has some interesting properties of its own. I'll cover one property right now, which is a into b modulo p. Like if you're going to do like a into b modulo p, where p is a prime number, by the way, where p is a very big prime number, or any prime number for that matter. It is a modulo p into b modulo p, the whole thing modulo p. This is what students miss out, the whole thing modulo p, right? So this, whenever we do multiplication with a prime number, modulo with a prime number, you're supposed to do a modulo p into b modulo p, the whole thing modulo p. So how does it affect us? Well, now we were supposed to output the answer under modulo, right? It's not enough to just at the end just say, okay, I just have to do prods t tc modulo p. No, that will finally format your answer correctly, but it doesn't solve the problem of multiplying big numbers, because your numbers here are being multiplied are really big. Instead, what we'll do is, and this is what you should do in most advanced questions, is you should keep a mult function, right? And what this does is it takes two I think operands, and like three operands actually, a, b, and the prime number itself. And what you actually just do is product is equal to a modulo p into b modulo p, the whole thing modulo p, right? And you're just going to return this, not just return product. That's all you're going to do. So now wherever we have the multiplication, we are instead do that multiplication under a modulo. Instead of multiplying it raw, we're going to do mult facts of this into I into that prime number, right, which we'll call as p right now, and we'll define p in another place. Similarly here, mult of prods of I minus 1 into facts of I under p, and p, let's define it initially as well. P is nothing but 10 raised to 9 plus 7. This is a very standard prime number that most advanced questions use. You will have 10 raised to 9 plus 7. That's how I was just able to look at it and tell you that's a 10 raised to 9 plus 7. Again, let's look at it. 3 zeros, and then 6 zeros, and then the 9th zero plus 7, right? So it's 10 raised to 9 plus 7. Again, a very, very standard prime number that is used. You should by heart this 10 raised to 9 plus 7. It is one of the most common used prime numbers for such a use case. Now our run test case doesn't fail. That means whatever we added didn't really change anything in terms of the run test cases, and when we submit it, now all of our test cases actually pass. So that shows you that even smaller things, like even if you got the algorithm as dynamic programming, you still need to consider modulo, because without the modulo it's never going to the multiplication becomes too big. So just a recap of how we actually solved this question. We observed the pattern that you can actually use a previous value for the next value. In this case, if we are able to find out all the factorials till the maximum number, then we can also find the f of n, or the product till the maximum number, and we can for every query just simply refer to that instead of calculating it again for every query. So this is also called amortization. This is the thing of amortization. Calculate all the products till that point. So what you're going to do, amortization, just look this particular term up. You can all go back and look it up. What it basically means is the cost of getting the answer is amortized over this, right? So just look it up, or you can join our advanced course. We'll teach you what exactly it means. But it's this process of calculating it once, and so this cost is now amortized over all of the test cases. So now for each of the test cases we have zero cost. Actually we are just referring to this one. The cost is amortized, so that's what it's called, amortization. And again, a super simple question on the face of it. Like if let's say that the constraints were very little, let's say the constraints were 10 raised to 2, 10 raised to 3, you wouldn't even think about all of these things. But the moment the constraints go higher, see how it changes. And this is just day 1, day 2, day 3, day 4, day 5. You'll see it doesn't look like super difficult, but you need to know these techniques and tricks to be able to solve them. If you are someone who's looking to learn these kind of techniques, do check out our algorithms and data structures course. I'm your instructor there, and we have more such questions, not only on dynamic programming but all of the previously asked questions of the big product companies. We are doing this bootcamp. Go ahead, at least register. We have some free questions from Google, Facebook, Amazon, Uber, etc. You can go ahead and check out those free questions as well. And yes, if you have not yet signed up for the December daily challenges, please do sign up for them. This was today's challenge. I hope you liked it. I'll see you tomorrow again at 9 p.m. to discuss the challenge of day number 2. Wishing you all the best. Hope to see you on the Edyst platform pretty soon. Thank you so much, and have a great evening. Thank you all.